Okay, so we're going to start talking about the division algorithm, and the best way to think about it is that division model that we talked about before, where you are separating out into evenly sized groups. Because that's all division is you're taking a large amount of stuff, so in this case 726, and you're breaking it up into a certain amount of groups. And you have to make sure that each group has an equal amount in it. And so in this case, we're breaking it up into 6 little bins here, basically. And so my question is, whenever I divide 726 by 6, that means I'm saying it's 6 groups of how many? Okay? Um, so I look at my model here where I have all of this stuff broken up, and it's pretty straightforward what's going on. I've got 700s. Well, I want to get rid of the big stuff first, so that way I don't have to, break down. I don't have to make teeny tiny groups first. So we should notice that this right here is a group of 6 100s, and I can break those up to be equally to equally fit in here. So I'm just going to split those. So it's like goes in here, goes in here, goes in here, and so on and so forth. I'm not going to draw them all out because that's going to take forever. Um, but so what ends up happening is that I have within each one a group of 100. So there's 100 in each one. And these are now gone because they've been broken up. That's how you can think about it. They're just kind of sitting on a table and you split them up, and so they're no longer something you need to worry about. And so this is going to make more sense later, but basically what we have here is that we have 100 at least. Okay, we may change that number. It may end up increasing, but probably not, because there's probably not 100 left for me to break up. And in fact, let me see how much is left once I've taken out 100 6 times. So I took out 100 6 times. That means I should probably subtract all of that 600 from there. So I have 126. That's what's left over. So I look at my 126 and I want to know, can I break this up further? Can I take any other big groups of 6? And in fact, in here, I have, should I do like a zoomed in version basically? Let's zoom into it. And so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 groups of 10 in here. And I can easily see, or hopefully we can all see, that there are 6 groups of 10 that I can take out. So 1, 2, 3, 4, 5, 6. So right here. Those guys are going to again get evenly split up into all the boxes, and then they'll be gone from this pile. Okay, so I'm going to put in a group of 10 to each one. So I'm just going to do a line if you guys don't mind, because the little rectangles never look good anyway and they take forever for me to draw. So I have now put in one group of 10 into each box. Yeah. And so I'm taking away another 60. So minus 60 here. So that leaves me behind with 66 blocks. So this is gone because it's been broken up, and there are 4 here. Hopefully you guys are okay with the fact that I'm going to regroup those 4 into here just so I can see 1, 2, 3, 4. I should have done those in a different color so that you guys can really see that it's just me redrawing that zoomed in 4, or a set of 4 there. 2, 3, 4. And lo and behold, that opens up another amount that we can take out, because I now have 1, 2, 3, 4, 5, 6. I can take out another group of 6. So this is all gone because those have been moved into there. And this group of 6 is going to get split up inside there as well. So 1, 2, 3, 4, 5, 6. And I'm going to change this number. I'm going to write that as 100 well, there's two groups of 10 in each little bin now. So I subtract another 60. And when I do that, sorry, if you hear any noise in the background, that's my dog. Um, so when I get rid of that, I don't have anything left over in my hundreds or my tens. I just have these ones. And there are, luckily, 6 of them. So this is going to be broken up into 6 groups. And so I'm going to put 1 in each bin. So there's 1 of those in each bin. And because that's 6 total, I'm going to subtract 6 from how much is left. And I now have equally split up all of my 726. Okay? And I've done something that looks kind of like what you've seen before in your division algorithm that you do normally. And the division algorithm is kind of tough because with multiplication, addition, and subtraction, you are working on the idea that that you are putting pieces together. But in division, it's almost like guesswork. And if you'll notice, in here, I subtracted 60 and I subtracted 60 again. That was me guessing as to how much I could take out. And that's what this process ends up being, is that your division is you're taking away parts and equally breaking them up and just doing it over and over again until you get a final answer. So let me pause this real quick. One more point to make before I erase all of this is that we have 121 as our answer up here from the constantly subtracting groups of 6. That is what is in each bin. 100, and then the 20, and then 1 more. Okay? So just to show the parallel between what we did here and what we do normally, the first question you ask yourself whenever you're normally dividing is you say, how many times can the outside, or 6, go into the first digit, or 7? And so how many times can 6 go into 7? Well, that's 1. And you're not actually asking yourself how many times can 6 go into 7. You're asking how many times can 6 go into 700? Or how many groups of 6 do I have in 700? And in this case it's 1. So then you would again say 6 times 1, that gets you 6, and you would subtract. Now notice that here we don't put those extra zeros in. You put a 1 and you bring down the next place value, but you don't bring down the third place value. But I want you guys to consider whether or not it actually changes your calculations here whenever we continue this process. So then you ask yourself, how many times does 6 go into 12? Well, that's 2. And then you multiply 6 times 2 gets you 12, and you subtract. You get 0, and then you bring down the next value of 6. How many times does 6 go into 6? It's 1. Multiply by 6, and that gets you this, and so you get your 0. So the difference, let me erase, I'm sorry, I didn't realize that oh, my eraser's huge now. So this right here where you subtracted 6, oh, that's not good. Sorry, I thought I clicked the pencil. So where you subtracted 60 twice, I want you guys to consider, have I subtracted 60 twice here? What does it mean to bring down the 2 and the 6? What does bringing down actually mean? What is actually happening? Keep that in mind, maybe even pause the video and think about it for a second, and then we'll continue on and see if that kind of structure shows up again as we continue. I forgot to show you guys this last one. So we talk about multiplication in the area model quite a bit, but we haven't talked about division in the area model because it's much tougher. Basically, you start off with this figure here where you know the area is 726, and you know that one dimension is 6, but you don't know what is the other dimension, how many hundreds, how many tens, how many ones. And so when you go through the process, then you'd have to say, okay, it's the same thing, just broken down into the portion of hundreds, the portion of tens, and the portion of ones that can be broken up. And so if I were to draw this out, I would have 100, 10 bars. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, crammed it in there. 10 bars of 10 and then 6 times here, and then I'd push all the leftover to be grouped into this tens place. And oh no, wait, I did that wrong. I'm sorry. Let me pause this real quick and show you what I'm talking about in a better way. Okay, so I'm sorry. What I was basically saying is that you could arrange it in this area format here where you have 100 6 times and then 20 6 times and then 1 6 times. The thing is that this is like, I don't know that I would be able to come up with this unless I either had the manipulatives in front of me to play around with, or I had already done a calculation like this or a calculation like this. So the area model, while it does provide that good visual after you've done the division, it may not be as useful for students first learning this concept. Okay, we're gonna move on. Okay, so something interesting that I don't think most people know about. We call what we do when we divide by hand long division. I don't think most people know what short division is. I actually had not heard of it until I started teaching this class. And so I will introduce it. I'm not going to expect you to have this memorized or understood. It won't show up on the exam, but some people might find it useful. So we're going to go with the long division first. And very much like what we did with the 6, we're going to just go with the standard division algorithm. So we ask ourselves, how many times does 5 go into 2 or 2,000? It doesn't. So I'm just going to say a 0 there. If I wanted to, I could do 5 times 0, put a 0 down here and subtract. I'm not going to do that. How many times does 5 go into 28? Well, that would be 5 times. And I would multiply 5 times 5 to get 25, and I would subtract 3. Okay, and of course, you would, if you were doing this using the method that we just talked about before, you would actually be subtracting 2,500, and you would subtract, and you would get 380. Doesn't change it. Hopefully you guys have come to that conclusion. Putting the zeros does not change the way the calculation works. But in short division, you would still go through the same question, 28 divided by 5, and you would get a 5. But instead of writing down the 3, or doing the subtraction and writing down the answer down below, you would, let me erase and make some space in here. Sorry, I didn't realize that I had crunched this together so much. Take that overhang. Sorry, give me just a second, guys. So you would actually write a little 3 up above to show you that there is a remainder of 3. And then the 880, or the 80 should still stay. Hopefully that's enough space for afterward. No, let's get just a little bit more just in case. Okay, so we'll continue and you'll see where we're going from here. So over here I ask myself, how many times does 5 go into 380? Well, that would be a, sorry, I blanked, 7 to get me 35, or 350. I'd subtract, and I'm only putting the 0 so that you guys can see that it doesn't change it. So I do my subtraction, I would get a 30 again, a 3 left over, and over here, give me just a second. Sorry. So over here, you would want to still do the same calculation. If you don't end up dividing 38 by 5, you've thrown the number off. But there isn't exactly a 38 unless you look at this remainder. And that's actually what you do. You'd say, okay, so I divided 28 and got my answer, including this remainder. Well, that's what I will start to do my next division. I would do 38 divided by 5. And you'd get a 7 with, as we saw, a remainder of 3 after you've done the calculation. And so you would put in another remainder 3 there. And so when you go through to do your last subtraction, you're going to do a 30 divided by 5. And so over here, it's a 30 divided by 5. Oops. Sorry. So it's 30 divided by 5 in both of them. So, well, that's 6. And that's 6 there. And there's a remainder of 0, so you're done. okay? Because here, 5 times 6, that's 30, and you subtract, so you get 0. So just wanted you guys to see short division. I don't know if anybody will actually use it, but if you do, no problem with me. Okay, so the next problem I want to do with you guys is division with a 2-digit divisor. And hopefully you'll notice here that I actually have the multiplication facts for 32 written out. And I want you guys to consider, why would I do that? Why is that valuable to me at all here? And so if you're thinking, you know, well, I could just figure it out as I go, that's totally fine. And if that's how you would like to work on these things, there's no problem. You do not have to write all this out. I don't expect that, but I want you to see while I'm working on this where I'm getting my values from, so it's pretty quick. So if I'm looking at, I have this problem written down twice because I'm going to do our standard method first, and I'm going to show you, well, no, actually I'm going to show you the place value method, and then we'll move to the standard. So I want to ask myself, how many times does 32 go into 2000? And that might sound like a kind of strange question, and honestly, I can't really look at the way, no, I'm so sorry. No, I don't want to start by the largest place value. I want to start in the smallest place value. So 32 can't go into 8. It can't go into 18. What am I doing? No, that's all wrong. Ignore that. I'm sorry, guys. Give me a second. Let me pause this real quick. My notes are shuffled. Okay, so I was right the first time, and I don't know why I doubted myself. I was just not explaining it right. But basically, I want to ask myself, just in general, how much I can fit this 32 into. So if I do about 2,600, and I divide that by 32, I'm looking over here, and so I can't fit, so if I look at 32 times 8, that's 256. If I did 32 times 80, that would be 2,560. That would mean that I can probably do 32 times 80 and fit that in here, okay? So I'm going to put an 80 down, and I'm going to multiply that out to get 2,560, okay? So I'm trying to guess how many groups can I take out without having to do so many extra steps like I did with those drawings of the 726 divided by 6. So when I do this and I do my subtraction, I get 58 right here, okay? And so I have done this with my remainder, so it's approximate, okay? That was me trying to find the approximate amount. And 58, you know, that's larger than 32, so I know that I can still subtract, but it's still pretty close to 32. I've gotten most of my chunk of this number down. So now I want to ask myself, okay, well, can I fit 32 into 50? Because that should make this a little easier for me to figure out. And look at my numbers over here, and 64 and 32, those are my smallest numbers. So I can't get past 1 as my fact family there, or my fact. So 32 times 1 is as much as I'm going to be able to fit into 58. So I'm going to put a 1 here, okay? And so I have 32 times 1, 32, and when I do my subtraction, I'm going to get 26, okay? So the amount of 32 groups that I was able to fit in was 81, okay? And I do have a remainder of 26. Now this is how people started teaching division algorithms. So not what we've talked about where we work with the place values and we would look at, you know, how many times can I fit, you know, how many groups of 32 do I have? It gets really tough whenever you're working with 2 place values. And so it's been taught a lot of different ways. But this is kind of a mess because you have to look at approximating first, and you have to kind of take guesses as to how much you can fit in, and you're working with the larger numbers and then putting them together with the smaller values, it's very confusing. So that's why we developed our standard algorithm. And don't worry, I'm almost done with this video, by the way, guys. I think my dog is snoring in the background. So if I do 2618 divided by 32 with my standard algorithm, first I ask myself, can it go into 26? And that's clearly a no. Can it go into 261? That's definitely going to work. So I put an 8 here, and I get 256. When I do my subtraction, I end up with 58. Is it 58 what I get? No, yeah, a 5 here, and then I drop down the 8. And then 32 can only go into 58 one time. So I have 32, I do my subtraction, and then I get 26. That is smaller than 32, so that is my remainder. We have not gotten into fractions yet, so that wouldn't be something you can consider. But that's the standard. Once you start working with multiple place values, a fact table can be very helpful, but only if you're starting with the smallest number, or with the, only working with just ones digits, so 2, and then 26, and then 261, whatever you can. It's something that once we get past a certain place value, a lot of people say, well, that's not worth my effort, but it is something you need to know how to do, and a fact family is probably the easiest way for me to do these kinds of things. So we're done with multiplication and division. They're standard algorithms in base 10. I'm going to make one more video for multiplication and division in different bases. So let me pause this video. Oh, sorry, let me stop this one.